Today we're going to be talking about rational expressions where we're putting all four operations together, so addition, subtraction, multiplication, and division. We just want to make sure that we're watching and remembering our order of operations. So that means we want to do parentheses first, then multiply and divide from left to right, and add and subtract from left to right. So let's take a look at our first example. We have the quantity 3x plus 5 over 3x squared plus 4x times the quantity 1 divided by x plus 5 minus 2 divided by x plus 1. So we're going to deal with our parentheses first. So in the first parenthesis, what we can do is take a GCF of 3 out in the numerator and a GCF of x out in the denominator. Over here in the second fraction, so we're going to kind of keep that by itself for the current moment. I'm going to draw a line here just so we can keep track of our work. Here we're subtracting, so that means that we're going to make that be an addition and a negative sign up there. And then we got to get a common denominator between these two things. So our common denominator would be x plus 5, x plus 1. The first fraction is missing the x plus 1. So when we multiply by the 1 that's already there, we get x plus 1. The second fraction is missing the x plus 5 from the common denominator. So distributing that in, we get negative 2x minus 10. So let's keep cleaning this up. We'll come here. So we have x plus 5, x plus 1. And then combining like terms, we have a negative x minus 9. Alright, so we're going to carry this part down here. This fraction is going to stay the same. And for this fraction, the only other thing I'm going to do is take out a negative 1 GCF from the top. You wouldn't necessarily have to do that, but it oftentimes will help find another common factor potentially in this process. So the x plus 5 and x plus 5 can go away. X is part of a monomial, and so is this x. That means that we're going to have negative 3 times the quantity x plus 9 over 3x plus 4 times x plus 1 as our first answer, first part of the answer. And then our restrictions, you just got to be careful where you're looking and what operations we had. So here we were simplifying a rational, so that means that our restrictions would be from just the denominator. So we would have x can't equal 0 and negative 4/3. In our other fractions that we were dealing with, we were adding or subtracting, so we look for the common denominator there, and that means that we would have restrictions of negative 5 and negative 1 as well. Alright, let's take a look at a dividing question here. So we have 2 divided by x plus 3 divided by y. That quantity is being divided by the quantity negative 5 divided by x plus 7 divided by y. So here we're going to deal with both pieces individually in the fractions. So we're getting a common denominator between these because we're adding. And that common denominator would be xy. So the first fraction is missing the y. And the second fraction is missing the x. Now you could rearrange the order of these if you want to be in quote standard form where the x comes first, but it's not necessary. Again, I'm going to draw a line here just to keep them separate. So over here, our common denominator is also xy. First fraction missing the y. Second fraction is missing the x. So we have negative 5y plus 7x. Now we're dealing with a division question. Alright, so we're going to keep the first one the same, and you notice I did change them to have the x first. And the second one we're going to flip, and again I'm going to make them have the x's come first. With this, these are in parentheses, so the only way to get rid of those common factors is if those parentheses are exactly the same, which they aren't. So we can't get rid of any parts of those binomials. But this x and that x can go away, and that y can go away because those are part of monomials. So 3x plus 2y over 7x minus 5y is the first part of our answer here. In terms of restrictions, we had addition, so we're looking just the denominators. of those, and then we had division, so bottom, bottom, top. Since there are two variables, remember we're solving for the first variable alphabetically, unless necessary otherwise. So here we can say x can't equal 0. Here's where it would be necessary to have y can't equal 0 as well, because that's part of a monomial. The last one we have to look for restrictions for is this 7x minus 5y. So we're going to solve for the first letter alphabetically, which would be x. So we would add the 5y over and divide by 7. So there would be your restrictions. These questions are going to follow those same steps. It's just a matter of what operations you have. So in this example, we have 2 over x plus 3 plus 5x over x squared minus 9. That whole quantity is being divided by the quantity 4 divided by x plus 3 plus 2 divided by x minus 3. So here we have, again, two different pieces that we're going to be dealing with. So I'm going to draw a line just to keep track of my work. In getting a common denominator between these two pieces, I do need to make sure that I factor all denominators as much as possible before we can find a common denominator. This means, looking at these two fractions, that the common denominator would be x plus 3, because they already have that in common, and then x minus 3, because we need it from this second fraction. Now, the first fraction has the x plus 3, so it's missing the x minus 3. Distributing that in, we get 2x minus 6. The second fraction has both pieces of the common denominator, so we just need to carry along that 5x. Combining like terms in the numerator, we end up with 7x minus 6. We're going to do those same steps here in the second fraction, or the second set of parentheses, before we can work with the division piece. So they're already factored denominators as much as possible, which means now we just have to find out how we got from the old to the new. So this first fraction is missing the x minus 3. So that's going to give us 4x minus 12. And the second fraction is missing the x plus 3. So that's going to give us plus 2x plus 6. And cleaning that up, in the numerator, we're going to get 6x minus 6. Alright, now we have a division question. Remember, this is still a division bar in between these. So the first fraction stays the same. And the second fraction we're going to flip. Now, when we flip this one, we do want to make sure that we're factoring anything as much as possible again. So the 6x minus 6 that's coming to the bottom has a GCF of 1 that we can take out. That 7x minus 6 is part of a binomial, so you can't get rid of any of those parts unless it's the same as a parenthesis in the bottom, which it's not. So the x plus 3's go away, the x minus 3's go away. The first part of our answer is going to be 7x minus 6 over 6 times the quantity x minus 1. And it could be something that you can keep this in parentheses if it helps you to notice that you can't get rid of those 6's. You can't simplify those at all. In terms of restrictions, we're going back here. We had addition and subtraction, so that means that we're looking for just the denominator pieces. So that would give us x can't equal a positive or a negative 3 from those two pieces. Since it was division, though, we do need bottom, bottom, top. So that does give us another restriction of x can't equal 1. Remember, this 6 is a monomial that does not have a variable with it, so it does not cause any more restrictions to happen in the problem. Our last example here is going to be the quantity 2 over x squared minus 4 minus 1 over x minus 2. That's going to be divided by the quantity 2x plus 5 over x plus 2. Alright, so we're dealing with the first set of parentheses over here. I'm going to change that subtraction to be plus a negative so that I don't forget about the subtraction. And we're going to factor all denominators. So that means we're going to have x plus 2, x minus 2 here. Now, the common denominator would be x plus 2, x minus 2. And the first fraction has everything that it needs, so that's just going to carry along the 2. The second fraction is missing the x plus 2. You have to be careful. This is where we're distributing that negative 1 in. So that's negative x minus 2. Cleaning all of that up, we have, let's just put our fraction bar here, x plus 2 times x minus 2, and that just gives us negative x in the top. Now, if we're looking at this second piece here, there is nothing to factor with any of those. It's just one single fraction, so we can go ahead and flip it and multiply. So any binomials that have already been factored or can't factor anymore, I like to put in parentheses so I don't try and cross off wrong pieces. All right, the x plus 2's are going to go away, and that's actually the only thing that simplifies in this. So we have negative x over x minus 2 times 2x plus 5. That's the first part of our answer. For restrictions, again, over here we had an addition question, so our restrictions there would be x can't equal positive or negative 2. Since we had division, we need to make sure that we're doing bottom, bottom, top. So we need to add the restriction of negative 5 halves to this question as well.